Mitochondrial donation. A breakthrough in IVF technology. A cautious triumph in genetic engineering has led to the birth of 8 healthy babies, free from a devastating disease. This innovative IVF technique, developed by UK scientists, has sparked both celebration and controversy. Mitochondria, the tiny powerhouses of our cells, can sometimes carry genetic mutations that lead to mitochondrial disease. Affecting around 1 in 5,000 people, this disorder can cause a range of debilitating symptoms and, in severe cases, early death. With no cure available, prevention is key. For women with damaged mitochondria, the options were once limited to donated eggs or adoption. However, a groundbreaking technology, mitochondrial donation, offers a new path. This process involves creating a composite egg, combining the mother's egg with the donor's healthy mitochondria. The resulting baby inherits 99.9% of its DNA from its parents, with only a tiny fraction, 0.1%, from the donor. But here's where it gets controversial. Some countries, including the US and France, have banned this technology due to concerns about human germline genetic modification. The lab-mixed DNA will be passed down to future generations, and the long-term consequences are unknown. And this is the part most people miss: the potential for mutations to occur. While the Newcastle research team's work has resulted in healthy babies, some embryos developed mutations in their mitochondria. This raises important questions about the stability of the process and the need for further understanding. The scientists and medics involved have been praised for their meticulous approach, bringing joy and hope to families. Yet, as an experimental technology, caution is warranted. The cost implications also pose a challenge, with the NHS unlikely to be able to provide this treatment to all who need it. Despite these complexities, the groundbreaking nature of this research cannot be ignored. It offers a glimmer of hope for families affected by mitochondrial disease and highlights the potential of genetic engineering to transform lives. So, what do you think? Is the potential benefit worth the risks and ethical considerations? Share your thoughts in the comments and let's spark a conversation about the future of genetic innovation. 3-parent babies. A breakthrough in preventing inherited diseases. The potential of a third parent's DNA to avert inherited diseases is a groundbreaking development in genetic science. Mitochondria, often referred to as the cell's powerhouses, play a crucial role in energy production within our cells. Recent findings from a significant study have revealed that scientists can now help prevent certain severe genetic disorders by creating what are known as 3-parent babies. This innovative approach has been successfully applied by British researchers, resulting in 8 healthy children, whose ages range from less than 6 months to over 2 years. These families have faced the burden of rare yet often fatal inherited mitochondrial disorders for generations, as detailed in 2 pivotal papers published in the New England Journal of Medicine. The cohort includes 4 boys and 4 girls, among them a pair of identical twins. While the initial results are promising, researchers emphasize the need for extended monitoring to ensure the long-term safety and efficacy of this technique. This achievement is being celebrated as a significant milestone in the ongoing effort to leverage advanced genetic technologies to empower more women to have healthy children. Doug Turnbull, a neurology professor at Newcastle University and a key figure in the development of this technique, expressed the emotional toll of mitochondrial diseases on families, stating, "Mitochondrial disease can be devastating for the family. It can be tragic. This is an important breakthrough, a big step forward." The excitement surrounding this research is palpable among families, medical professionals, and scientists alike. Dietrich Egli, an associate professor of developmental cell biology at Columbia University, described the work as a landmark advance, emphasizing its pioneering nature and advocating for the removal of federal restrictions on similar research in the US. However, this approach is not without its critics. Some express concerns about the potential risks involved and fear that it may pave the way for genetic manipulation that could lead to the creation of designer babies. They argue that any genetic alterations could be inherited for generations, raising the possibility of introducing harmful mutations into the human gene pool. Stuart Newman, a professor of cell biology and anatomy at New York Medical College, voiced his apprehension, stating, "It's dangerous. It's biologically dangerous. And then it's dangerous culturally because it's the beginning of biological manipulation that won't just end with preventing certain diseases, but will blossom into a full-fledged eugenics program where genes will be manipulated to make designer babies. Currently, U.S. regulations prohibit the use of this procedure for producing children. Nonetheless, a New York doctor claimed in 2016 to have created a 3-parent baby for a Jordanian family in Mexico. Meanwhile, Australia has legalized this practice, and clinics in countries like Greece and Ukraine have employed similar techniques to assist infertile women in conceiving, although the effectiveness of these methods remains uncertain. François Baylis, a distinguished research professor emerita at Dalhousie University in Canada, raised concerns about the normalization of genetic tinkering in the pursuit of an ideal child, questioning the societal implications of such a mindset. Mitochondrial disorders can lead to severe health complications, including paralysis, heart failure, brain damage, strokes, and blindness. Children born with these disorders often endure short and painful lives due to defects in mitochondrial DNA, which is inherited solely from the mother. The innovative solution tested by British scientists, known as mitochondrial donation, involves extracting the nuclear genes from the fertilized egg of a couple wishing to have a healthy child. This nuclear DNA, which constitutes the majority of genetic material and determines most traits, is then transferred into a fertilized egg from a healthy donor, which has had its own DNA removed except for the healthy mitochondrial DNA. This process, referred to as pronuclear transfer, allows the embryo to develop with healthy mitochondria before being implanted into the womb of the woman seeking a genetically related child. Consequently, the resulting baby inherits the primary genetic traits from the 2 parents, along with a small amount of mitochondrial DNA from the egg donor, hence the term 3-parent baby. The recent study involved 7 women at high risk of passing on serious mitochondrial DNA mutations to their children. The researchers found that the mother's disease-causing mitochondrial DNA mutations were either undetectable or present at levels unlikely to cause disease. Robin Lovelbach, a developmental biologist at the Francis Crick Institute in London, highlighted the emotional toll of watching a child suffer from such conditions, stating, "A child with one of these conditions can be in a lot of pain, suffer all sorts of problems and die. It's truly horrible to have to watch your child slowly die of something that bad. It's heartbreaking." For women at risk of having children with serious mitochondrial diseases, this provides them with an option to have children without suffering. It's very encouraging. According to Turnbull, all the children born from this study are thriving and meeting their developmental milestones. However, Baylis and others caution that there may be unforeseen risks to the babies, the mothers carrying them, and the egg donors, such as the potential for dangerous ovarian hyperstimulation. She also expressed concern about the societal implications of valuing only one's genetic material, suggesting that couples at risk of having children with mitochondrial disorders should consider other options, such as adoption. Turnbull acknowledges that this research is still in its early stages and requires further follow-up and monitoring. He remains optimistic, stating, "The results so far are very encouraging." He also reassured that reproductive technologies are subject to strict regulations in Britain and many other countries, arguing that there are sufficient safeguards in place to prevent a slippery slope toward designer babies. Others emphasize that this technology is fundamentally different from gene editing techniques like CRISPR, which have raised similar concerns about designer babies. Lovelbach asserts, "This is totally different. This is using a method that is avoiding a serious disease. If you care about people's health and their desire to have genetically related children, then I see no reason why you should not accept these methods." Breakthrough. Babies born with DNA from 3 parents to prevent genetic diseases. Breaking. Science just redefined parenthood. Meet the world's first 3-parent babies free of deadly genetic diseases. Imagine rewriting the rules of human inheritance to save lives. That's exactly what British and Australian researchers have achieved, announcing the birth of 8 healthy babies using a groundbreaking IVF technique that combines DNA from 3 people. But here's where it gets controversial. Critics argue we're playing with fire in the genetic code of future generations. Let's unpack this medical marvel. Every human cell contains 2 types of DNA, the vast majority determining your eye color, height, and personality, comes from chromosomes inherited equally from both parents. But there's a hidden player. Mitochondria, tiny energy factories in cells with their own DNA passed exclusively from the mother. When these mitochondrial genes malfunction, they can trigger catastrophic illnesses like Leigh syndrome, causing muscle wasting and organ failure, or MELAS, leading to seizures and developmental delays. Here's the breakthrough. Scientists at Newcastle University and Monash University developed a mitochondrial replacement therapy, MRT. They carefully transfer nuclear DNA from the mother's egg, containing her chromosomal genes, into a donor egg with healthy mitochondria, then fertilize it with the father's sperm. The result? An embryo with 99.9% of the parent's DNA, plus a tiny mitochondrial battery pack from the donor. And this is the part most people miss. The donor contributes less than 1% of the child's genetic material, comparable to receiving a blood transfusion, as geneticist Robin Lovellbadge explains. You'd carry more foreign DNA from a bone marrow donor, he notes. Yet this 1% has sparked global debate. Since 2016, when the UK became the first country to legalize MRT, 35 couples have been approved for the procedure. Of 22 attempted embryo transfers, 8 babies were born free of mitochondrial diseases, with 1 pregnancy ongoing. While 1 infant showed slightly elevated abnormal mitochondria, levels remained below the disease threshold. But here's the twist. The US bans this technique outright. Why? Federal law prohibits editing heritable human DNA, a policy Dr. Zev Williams of Columbia University calls a regulatory limbo stifling medical progress. Meanwhile, advocates like Liz Curtis, who lost her daughter Lily to mitochondrial disease, argue this isn't about designer babies but preventing unimaginable suffering. Families like mine live in constant fear, says Curtis, founder of the Lily Foundation. This isn't a choice, it's a lifeline. Now the million-dollar question. Are we crossing an ethical line by altering human embryos, even to prevent disease? Critics warn of unpredictable long-term consequences, while supporters counter that existing embryo screening methods often fail for mitochondrial disorders. Dr. Andy Greenfield of Oxford University insists MRT is scientific innovation at its finest, reserved only for high-risk cases where no other options exist. So where do you stand? Should more countries follow the UK and Australia in allowing mitochondrial replacement? Or does the 1% donor DNA open Pandora's box for genetic modification? Drop your thoughts below. The future of reproductive medicine is being written right now. Report includes contributions from Newcastle University, Monash University, and the Lilly Foundation. Funding disclosures: Howard Hughes Medical Institute and Robert Wood Johnson Foundation.